this is going to be a session about the Lost Crypt, which is a sample project that we at Unity recently released on the Asset Store. We first showed off this project at Unite Copenhagen 2019, which was last September, where we showed it in the keynote and various tools that we used to create the project, from rigging to lighting to sprite shape and all kinds of different 2D tools. But this specific webinar session is going to be focused on the new 2D graphics features because we've added a wide range of new graphics features to the 2D toolset. And I'm mostly going to be showing off how these tools work and how they could be used in the scenario of the Lost Crypt, but also in general purpose for your projects. So you should be able to learn how to add 2D lights to your project or 2D shader graph and things like this. So my name's Andy. I am a global content evangelist at Unity Technologies. I joined mid-2013, so I've been with the company a while. I don't think Unity had any 2D tools when I first joined. No, it definitely didn't have any 2D tools when I first joined. So it's been interesting to see the evolution of the 2D tools being added and then improved and evolved over the last 6.5 years. And it's really, really exciting to see all the different things that we're adding and sort of opening the doors to. I'm based in Copenhagen, where it's currently raining and very, very cold right now. I'm sure a lot of people on the call are in much warmer, nicer places, weather-wise. I'm also on Twitter, where I kind of share different Unity information, tips, tricks, and different things. So feel free to chat and talk about it, talk afterwards. So I've got a range of different talk topics to look at. So the first one is the universal render pipeline and how this has a 2D renderer sort of integrated and set up, which you need to enable to be able to use a lot of new 2D graphics tools. So I'll show a little bit of how these things are set up, but we have lots of information afterwards. We have lots of information on blogs and videos on how on about the universal render pipeline in general. And this session is going to specifically look at the 2D renderer. And with the 2D renderer comes a set of different things. So one thing I'm going to look at is 2D lights, and there's different types of lights, different settings, and we also have this light blend style system, which I'm going to have a look at as well, which allows you to set up some interesting light influences to your sprites and art assets. I'm also going to look at 2D shader graph. Shader graph's a feature that we've been showing off for maybe like 2 years or so, since the beginning of 2018, actually. And shader graph has evolved to add sprite support and also support for, say, 2D lights and things like this, or sprites that have influence from 2D lights. And these things sort of go very well hand in hand. So I'm going to show how these things are configured to work together. And I'll show a little bit about the post-processing, which comes with Universal Render Pipeline and is used in this project. So before I jump into the editor and spend time with the demo, I want to give a big thank you to Back to the Game Studio based in Montreal, a great studio that we worked with, collaborated with, and pretty much all the artwork that you're going to see is provided and drawn and created by them. So huge thank you to them. And Richard from the studio is in the chat as well if you have any more direct questions about what they do and also how the artwork was generated and things like that. So a big thank you to them. It was a lot of fun working with them. It was a great experience. So I literally have 4 slides. So I'm going to spend the rest of the presentation actually in the editor having fun and doing different things. So if you haven't seen it before, this project is called Lost Crypt. And Lost Crypt is basically a vertical slice project that uses a wide range of different 2D tools to create a side-scroll platformer with lots of different effects. Everything I'm showing you right now is actually downloadable from the Asset Store. I actually downloaded downloaded this version that I'm showing right now this morning. Obviously, I had it before when working on it. So everything you can see, you can download right now or straight after this presentation as is. I haven't actually changed anything. So if I go into play mode, let's have a look at what is actually in this project. Save a bunch of shader graphs. So you might not be able to hear audio, but that's fine. I can talk over it, talk over what you're going to see. So The project has a character, and this character is called Sarah, and she runs around, and she's actually rigged and animated using the new 2D rigging and IK system, including her hair. Her hair is physics driven. So that's also using the IK system, but it moves dynamically and flows when she moves around. And what you can see is that we have different types of environments. So we've got this foresty environment with particles in the air. We've got some swaying trees. We've also got some flowers and things lit up on the ground. Those all put together, or those all lit and illuminated using the 2D lighting system. She also moves down into these sort of like ruins where we have sort of different types of light influence, different types of highlights on the environment. And we also have down here a crypt area. And this crypt area shows kind of lights and particles and shaders and things in a inside environment. So we've got these flames here. We also have these sort of like emblems. And we have this water as well, which is created using shader graph. And if I move along to the end, I'm going to pick up this staff, and then this then plays a timeline sequence, controlling particles, controlling lights, and all kinds of different things. Notice that it fades from day to night. All the particles then converge, and then a big ripple shockwaves through the environment. That ripple is actually done with a 2D light, which I just scaled up very quickly. And now we have the character has changed form. She's got this new outfit, but she's also got a wand in her hand, which is using a 2D light that's lighting up different things around her. So you notice the normal maps of the cave are being influenced. The light is shining on her, and it's also getting picked up in the reflective water at the bottom. And as we leave the temple, or leave the crypt even, and come out into this environment, what you'll notice is that the environment has changed to be this more nighttime, darker scene. And we have these little fireflies floating around this tree. And we have these forest spirits. And these forest spirits, you'll notice with this kind of, I guess, dog creature, they have this very subtle fresnel around the outside. But as the wand and the character gets closer, you'll notice that finer details appear. And this is done entirely with shader graph as well. So there's lots of different parts in this demo. It's a very simple vertical slice, but it shows off lots of different things in this kind of one level environment, from rigging to graphics to physics to all kinds of different things. Now I'm going to specifically focus on the graphics part. So if I leave play mode and switch to the scene view, let's have a look at the graphics. So as I mentioned earlier on, yeah, there's no audio playing. There's actually audio in the demo, just no audio coming through Zoom. That's so I could kind of talk over it, I guess. As I mentioned, this project uses the universal render pipeline. The universal render pipeline is a render pipeline using the scripted render pipeline technology that we're working on that opens up a wealth of different tools and features once you apply it to your project. I have this installed through the package manager. So if I go to Window and Package Manager, I have the universal render pipeline installed. And once it's installed, we can then add the 2D renderer to then use. And here I have two assets. One is the universal render pipeline asset. So this is kind of like global graphics controls of different things like HDR, anti-aliasing, lighting, post-processing, all kinds of different things. One of the most important things to look at, one of the most important things to apply if you want to use the 2D renderer, is to go to the renderer list and add this 2D renderer option. And with the universal render pipeline installed, if I go down to rendering, universal render pipeline, we have this 2D renderer option here, which then creates the asset that is assigned here. If I have a look at that 2D renderer asset, where you'll notice that we have some more 2D renderer specific options, such as light blend styles, HDR emulation scale, and a couple of other things I'm going to go into a little bit later. And with that assigned, and also in the project settings, under the graphics section, with the universal render pipeline assigned, you can then get going. Once you download this project, it automatically has all this stuff set up, so it could be a useful resource if you want to then set it up in your own projects. So with this assigned, this opens up a wider door to a lot of new tools. One of these tools is shaders. So we obviously have shader graph, which we can use to author shaders and effects. But one of the things that the Universal Render Pipeline comes with, and you notice in this material option here, is under 2D is this sprite lit default. And sprite lit default shader is one that is influenced by 2D lights. So once you start placing 2D lights around, anything using this built-in shader or the sprite lit shader graph, which I'll show you later, will be influenced by 2D lights. In this project, a couple of the elements are using this, and most of the actual elements are using shader graph. And once you have that set up, you can then start to use the 2D lighting system. And what you'll notice here in this scene is there's already a lot of 2D lights at work. What I'm actually going to do is, rather than focusing on these lights that are already set up, I'm actually going to hide them. So we've then got this very dark environment. So you can kind of clearly see what I'm about to do. And you'll notice that in the background, we've got these the environment pieces all already lit up, and these are because they're using unlit shaders. So they're not influenced by 2D lighting because they're just in the background. So let's have a look at different types of 2D lights. So with that Universal Render Pipeline installed and set up, if you go into the game object window and go to lights, you'll notice there's a new 2D option. We have several different settings of different types of 2D lights. Just like in 3D, we have directional light, point light, area light, spotlight. In 2D, we have similar versions, such as global light, point light, sprite light. So the first one to show you is a global light. So if I turn on this global light here, what it does is it applies a singular global color to pretty much all the sprites. So you notice I can sort of increase the intensity, darken the intensity. It's kind of like a directional light, but in a 2D world. So it's influencing everything that it's targeting. So if I choose like kind of this like blue type of hue, you notice that all these trees, which are using a sprite lit shader, they're being influenced by this blue global hue. So you use it to kind of set a nice ambience to everything in the environment. You have different controls such as color and intensity, which you're probably familiar with if you've used lights before. But one thing that is different with the 2D system is you can target the 2D lights to different sorting layers. So if you've used the 2D system before for painting tile maps or just creating 2D games, you've probably used the sorting layer system to put sprites onto different layers, such as background, foreground, UI layer, and things like this. The 2D lighting system ties into this. You can have certain lights pointed at different types of layers. So currently, this global light, this global blue fill light, is currently applied to all sorting layers. Now, if I go to no sorting layers, I can actually say it's actually placed only on this near background layer. So only the trees are going to get this sort of bluish layer. You can actually choose sort of which elements you want to be included in this with this light. So notice here, I'm actually going to set it up. So only certain elements are actually being lit by this global light. If I go to none and do like foregrounds, we can then just have the floor lit by this global light, whereas the background isn't. So the really cool thing with the 2D system, 2D lighting system, is you can not only create different types of lights, but you can also filter them to different layers and different channels. So that's the global light. So next one we look at is the point light, which is up here. So the 2D point light is basically an equivalent of the spotlight, the 3D spotlight and the 3D point light. And notice as I move it around the environment, it's going to cast this kind of circular range onto pretty much anything that is within the range. And if I position it somewhere like, let's position it in the trees such as here, we have these extra settings and extra handles to play with. So we can obviously do things like, make it sort of like a more red tinted light, or change the intensity of how bright this light is. There is some post-processing bloom being applied, so you notice it will glow a little bit more. But we also get some other settings and controls, such as sort of the angles and sort of the area that the light is being cast onto. So if I actually grab this handle, we can take the point light, the 2D point light, from being, an entire circle. We could actually change it into a spotlight quite easily and place it in the environment. So I'm going to cast it across these tree branches. And let's say we don't want this, we've now got this like hard edge across here, which might be cool for like, I don't know, a searchlight from an enemy in a game or something. But what I could actually do is actually grab these handles. And it's very intuitive that you can grab these handles and smooth out or position it in a way that you want it to look or render. And all of these settings are actually applicable here. So we can actually set the inner angle, not just from gizmos, but also in the inspector. So we can actually control a lot of how this light is rendering entirely from the scene view or the inspector view here. We could also do things like fall off intensity. So if I want to have, a lot more faded light that actually is faded over its range, then we can change this. Or if I want a more harsh, intense light, I can set this up as well. We can also change the fill. Basically, you just get a lot of tools that are a lot of fun to play with to really influence these lights. And I think Richard from Back to the Game Studio, Back to the Game in Montreal, said it was kind of like painting with lights, which is pretty cool. That you can sort of place these lights and paint them and think of them as kind of like light shapes that you can then combine. The other cool thing is you can actually stack and blend these lights on top of each other. So if I now duplicate this light, let's make another one here. Let's make like a more of a red tone. Let's lower down the intensity a little bit. Notice that we have like this red and green light inhabiting the same space. I could actually select these lights and click alpha blend on overlap. So rather than it's additive here, we can actually blend multiple lights together and they sort of bleed very nicely into each other. So now everyone's going to turn all their games as disco games with disco spotlights everywhere, but that would still be pretty cool. But you can take these lights and overlap them in lots of different ways. This project, when you dissect it, has lots of these lights scattered everywhere. On the trees, on the ground, that uses all these different overlapping lights to create kind of the end result. So that's the point light. It's pretty cool that we can control like this angled range. So if I go back to this light and let's reset it, let's actually reset it to a point light. So we've now got this point light here. Actually, let's just make a new one. So another thing that a lot of people have been asking about is normal maps. So we got this light here. So this light is obviously defining this range that light is being influenced here. So if I now go over to, actually, let's keep on these trees. What you'll notice is that this light is just filling up this space. It's not really influencing the normal maps that these trees have. This foliage, if I select the foliage, basically has this sprite sheet of all these different foliage types or foliage forms. We also have normal maps here, which are being applied to determine the influence from lights. You could also set this up using the sprite editor as well. So going into the sprite editor, so we have this foliage piece here. You can go to this new secondary textures drop down. We can now basically assign to a sprite different types of secondary textures that are going to come with it through the shaders. So you can set up these normal maps and bind it to these sprites. So these trees are all using these normal maps. So if I now go to this 2D point light here, currently it's not influencing the normal maps. Now, if I click this use normal map button and change the distance down just a little bit, what you'll notice now is as the light moves around these trees, it's actually using that normal map influence. So if I now like increase this a little bit, you'll notice that it's not as flat anymore. There's a bit more depth and a bit more detail to it. You can actually notice this a lot more inside the caves. So if I go down to the caves here, trim down the intensity just a little bit, maybe increase the actually volume opacity. So what you'll notice here is if I turn off the normal maps, the environment is like look at these skulls here. It's kind of a little bit flat, right? Where it looks pretty cool that we're lighting up this environment. But if you enable to use normal map on the lights, notice that as the light goes around these skulls and around this normal map, which is part of the tar map, it's actually influencing the fall off or the result of that normal map. It's tying into that. So you can now use these lights with these different normal map influences. It's pretty cool. It's nice when it all ties very neatly together. And this project uses normal maps for tar maps, the foliage, pretty much most things in the project is using normal maps. So it's a very good study or case study piece if you want to learn how to apply this to your own games. So the next light type I want to have a look at is freeform light. So let's turn this on here. So a freeform light kind of fits into not quite global lights or point lights, which are more, well, global light is global across things on a layer. Point light is more like a range-based shape. A freeform light is kind of, I guess, similar technology to sprite shape in that you define out an area for light to influence. So here we've got this shape, which kind of wouldn't be easy or straightforward to create using using a point light, but instead here with a freeform light, you can actually grab different points and kind of sculpt your light. So I can actually create this this shape around this tree and create this light highlight. So I don't know, some kind of area of my game, which is like a little bit more toned or stylized. So let's say at this point in the game, it's a bit darker, a bit moodier. Let's turn on the normal map influence as well. So we've now got like a little bit of normal maps. Change this a little bit. We could also set up like the volume opacity. So we could have this like a nice thick area that this light is influencing. You can do things like have the fall off intensity. So we could have basically like a sharp sort of light cookie or light area, but we could also increase the fall off as well. So we've got a very nice sort of fall off range with this light. So you can really use this to kind of block out different areas of light or areas of influence for different tones and different feelings and moods. This also works with the sorting layer system. So pretty much all the 2D lights will use the sorting layer system. So I could say this area only influences sort of, we could have this nice fog in front of the silhouette in the background. It's just a lot of fun to be able to set up these lights and put them at different locations and places. So if you want to sculpt lights, definitely freeform light is a pretty cool way to go. And we use freeform light in the project at the very end. So if I go over to this very end here and select this lights here, you'll notice that we have this light shaft coming through the rocks here. This is actually a freeform light being used to define this space. And how sort of like this light is influencing these tar maps here. So you can use this to sculpt. It's actually used inside the lights, inside these little alcoves as well. So you can get some really nice effects with using the freeform light. And notice as I turn on the lights, we've got this nice blue haze or nice blue mist in this environment. I didn't even intend for that to happen, I'll be honest, but it looks pretty cool. So that's the freeform light. There's one more light type I want to show you before I show you a couple of other really cool things, and that is a sprite light. And 10 points if you can guess what the sprite light does. It allows you to choose a sprite that you have in your project and use that as the light source or as the shape of the light. So if I go down here, I have all the sprites in my project. Let's go down here and let's use these sprite shafts. So you notice that this sprite that's been imported that looks basically are these shafts. So the sprite is pretty simple actually. It looks like this. Yep, it's simple sprite that's just been painted, has been created. And what you'll notice here is that as I apply this, it's basically going to cast light, and you get all the same settings. You can set the intensity, you can set like the color. That's looking. You can set like the normal maps. You basically get a lot of similar settings, but you're now using a sprite as kind of the filtering. It's a lot of fun to play with. It's a lot of fun to set this up for, I don't know, people are going to put Batman logos in the sky now. They're going to have lots of different interesting runes and lights. And actually these runes here, I think they use it, or they could use it. Yeah, so you can use sprite lights for lots of different sprite types. So we have this one here as well. So you can have some like lights influencing the environment here. We could use it as like we have these sunspots as well. So this project has lots of these, like 4 or 5 or 5 or 6 of these different types of lights sort of scattered around. So you can do some really neat effects using these sprite lights. So if I now go back and turn on the lights for the environment, let's have a look at kind of how these things are actually applied to this project. So we've got a global light that's being applied to everything in the scene. So we've got that like global fill light, which if I turn off, notice that we have less fill. We also have, just as a side note, I have set up this sort of discovery window, which basically when you start up the project will be available. And you can, when you start up the project, it will pop up. Or if you go to this Lost Crypt discovery asset, you'll notice that this discover window here is basically bound to lots of different elements and has information. So if I go to 2D lighting here, I've then set it up a link to global light 2D. So I can select this, and then we've now got the light selected. We've then got some lights at the tops of the trees. So it shows how this has been used to sort of set up the highlighting of the tops of the trees. We also got the freeform light. We basically got all these different different light settings here. So you can go through and play around with them. We also have here lots of different sunspots and lens light shafts all on the ground. So everything's stacked on top of each other and everything's combined to make this very visually pleasing scene. Another interesting part of this project, this isn't part of the 2D tool system specifically, but it's actually part of a script or a tool that Back to the Game created, was this day-night controller. So if I move this slider, and you saw this in the cutscene, if I move this slider in this light controller system, you'll notice it actually blends all the lights from a day setting to a nighttime setting. And it does this by using this root script, which then goes to the child objects and samples these gradients and applies them to the different lights. So you have this kind of centralized controller, which then influences all the lights. So all the lights are actually technically real time. You can have them flying around. You can have them on a lamp. The character was holding one when she gets the wand, and all of them can change as well. So you can dynamically blend your lights or blend your light details without having to import lots of different types of sprite setups. So lots of different, versions of your sprites. So as you can see here, when it's nighttime, we have this nice blue highlights along the tops of the trees, and that's just changing the color of that highlight light, which I just showed you. And again, like the discovery window has a lot more information on how like a lot of this works, and also pre-binds to all the selections, so you don't have to go hunting in the hierarchy. You can click the buttons and it will select it for you. So that's lights. Let's talk about masking or light blend styles. So one thing you might have noticed is that certain parts of the trees have a little bit more detail or a little bit more lights influencing them. So the tops here of the trees have a little bit more light influencing them, but not necessarily at the bottom. And this can be done in a couple of ways, but one way that's been implemented into the 2D renderer system is a light blend styles, our light blend styles. And if I go to the 2D renderer data asset, what you'll notice here is that we have a couple of styles set up and a couple not set up. So one that's automatically set up is default, which means that anything on the default light blend style will just receive lights as normal. Everything I've just shown you is how it's received. So up to this point, it's all exactly the same. Placing a light and it influences everything there. And if I go back to this point light, which is here. If I actually move this point light over here, it'll be interesting to show you this. If I move this point light here and tone it down just a little bit, you'll notice that as I move the point light round, it's actually going to light up everything that it influences. It's a very hot spotlight that's then lighting up everything in basically the same natural way. But maybe we don't want this point light to influence everything inside its radius to be, very harsh and intense. Maybe we want just the tips of the trees or the tops of these ruins here. Well, this is done using this masking or light blend system. So I have this default layer here, but you can add extra blend styles. So this one is for direct lighting. So just typed in direct lighting. You can call this anything you want. Emission, glow, it's up to you. We also have this mask texture channel, which you can choose. So here it's using the red channel. So anything using the red mask on a mask map for the sprite using the red channel will be influenced by these lights on this particular layer. We get a couple of other settings such as is it multiply blend mode, is it additive blend mode, subtractive, and things like that. So if I now go to this point light and change this specific point light from default lighting, so as it's lighting up everything that it's that's within that range, to direct lighting, what you'll notice is it's only shining light or only influencing light on the tops of the trees. So you notice as I place it here, this area is not being influenced as such, whereas the tops of the trees are being influenced. Now if I bring it over to these ruins as well, notice that the light placed here is not influencing the underside of this ruins, it's actually the outside edge. So we're getting a more harsher direct lighting. We're controlling how this light is actually influencing on this sprite. And it's funny because I was doing this in the office and I was playing around with this in the office. Someone's like, wow, that looks really cool, that 3D lighting. And I was like, it's not, it's actually a sprite. We're actually just painting or setting up where the light is being influenced. And this is actually done by importing another type of texture. So if I select these ruins, we've got the ruin sprite, which you just import as normal. You place in, it looks like this. It's pretty standard. We also have this ruins mask map here. And this is very similar to physically based rendering if you've done something like this before. So PBR will have a mask map that has like one of the channels is metallic, one of the channels is smoothness, one of the channels is ambient occlusion, one might be emission. You basically bake into red, green, blue, and alpha different data to use. And it's kind of the same principle when using it with this lighting system. In the red channel, you can bake in direct lighting, such as this. Green channel, you could bake in emission. Blue channel, you could bake in, I don't know, silhouettes and things like this. You can use these sprite channels. So if we have a look at the ruins here, you'll notice that it's a typically painted color or diffuse. And then here we have a influence in the color. So if I look at this red channel here, we've got a harsher tone of red that's been painted around the outside of the ruins, whereas the inside is a little bit darker. And if I actually go to the foliage, it's actually similar. So I go to this foliage piece here, notice that we have the normal map, which looks like this. If we have a look at the mask here, this is the same mask map, the red is applied to the tops of the trees, so it's being influenced here. And the green channel, you'll notice, has actually got little highlights or little spikes here. So we could actually have like an even finer glow or even finer detail just applied to the green channel. So using this light blend system, you can actually have lots of really cool effects like emission, direct lighting, and things like this. And in this specific project, we use it for highlighting the tops of the trees and highlighting the sort of outsides and areas of these ruins as well. It's very fun to play with, and you can get some really neat effects. And any light can influence this as well. So if I go to my global light and turn this on, let's turn all the lights off, just to show that the global light works with this. So the global light's now influencing everything. Notice the blue is being applied to every type of sprite. If I now switch this from default to direct lighting, we'll notice that now this blue light is only influencing the area of the mask map that I've defined it to, that the red channel has defined it to influence. So you can really be nice and selective and place lots of global light influence without having to really, manually author a lot of unique versions of sprites. It's very dynamic and very flexible. It's a lot of fun to play with. So we've now covered that masking system. The next thing I want to cover is shader graph. So switching a little bit, but I'll come back to masking in a little bit. So shader graph, this isn't going to be an introduction to shader graph. This is going to be more like the updates for 2D. We have got some materials and resources on shader graph and getting started with that. This is just going to cover what we've actually done to extend it for the sprite workflow or 2D renderer workflow. So everything you see on screen is pretty much using shader graph in some form. And there are some more obvious uses, such as this foliage here, or the wind is actually swaying backwards and forwards. That's all done procedurally through shader graph. And actually the tree trunks use the exact same shader to sway a little bit. It's not as noticeable. It's noticeable here. So these tree trunks are actually swaying backwards and forwards using that exact same shader graph as well. And we tried to tidy up the shader graphs as much as possible so you could actually lift this out from this project and actually use it in your own project. So if you want to apply winds different to foliage or rocks or whatever, grass, it doesn't matter. You can actually use the shader graph in your projects. Another use of shader graph that's interesting is the water. So we have the water down here that reflects everything above it as the character walks through the environment and things like this. This is done using a second camera that renders it to a render texture. And then we have a shader graph that then applies refraction and caustics. So let's have a look at how these shader graphs are set up. So this is the vegetation shader graph. I won't go through every single node because that will take a long time. That'll take probably an extra hour, but I'm just going to call out a couple of key interesting points. So if I zoom into the top here, and I've tried to group these blocks and these sections as much as possible so that you can either extract them or learn how the flow of data is going through. And a lot of these nodes here are actually all nodes you could use with 3D shader graphs. And we have noise, we have world position, we've got UVs. It's all pretty standard stuff. But the interesting change here is when you get down to the very end, we have this master node. And the master node is then the output of the shader graph. It's how your shader nodes and your visual effects from these nodes are then going to get output and then rendered onto your sprite or onto your mesh or onto your particles. And if I open up the shader graph menu and go to master, we have PBR and unlit and visual effect, which are already shown and already released. But with 19.3, we now have sprite lit and sprite unlit master nodes. And you'll notice that they're actually very similar. We have the sprite lit master node and the sprite unlit. And the only notable differences here is the mask and normal outputs into the sprite lit. So you can actually use the procedural, you can actually use like noise and procedural shaders to actually output the mask value that the mask lights influences, which is pretty cool. So you don't just have to use a mask texture. You can actually use, say, you can actually apply noise to something and then output noise through the red channel and have noise affected by lights, just specifically noise. It's pretty cool. And we also have the normal maps as well, the normal influence. Sprite inlet doesn't have these things. It's pretty standard for typical sprite shader, vertex position and color. But the other thing spritelit unlocks is 2D lighting. So actually any shader graph, any sprite using a material using the shader graph with spritelit master will be influenced by 2D lights. And you can see there's some pretty cool stuff in this foliage here. So in this shader here. So if you want to have your sprites have their sprite renderer asset. So if I find one of these vegetation, what you'll notice in the sprite renderer is we've got a reference to the sprites here. And we have the shader here. And if you want to take whatever sprite is being used in the sprite renderer, you can go to shader graph and actually type into reference _ main text, and it'll automatically pull it in. So you can create one shader graph, in this case, vegetation wind, and use it across all sort of influences from sprite renders, or all sprite renderers use this. So you don't have to make a new shader graph for each individual element. You can kind of make one global one and apply it. So all the particles in this project, you use 2 shader graphs for everything from the big exploding artifacts to the dust motes. They use like the same shader graph. Just using this reference allows you to unlock reusability. So the foliage uses the foliage is affected by kind of wind. We do this using a vertex position as well. So the vertex position is basically changing the offset of the wind of this sprite. And if I then go back to the scene view, let's go find this foliage here and select one of the foliage parts. There's a bunch of different settings exposed from shader graphs. So we could actually change the wind scale. We could actually change the strength to how much the wind sways backwards and forwards, the speed. Okay, that's a bit too much. We could also change the wind direction as well. Basically, you can control sort of how this wind is actually influencing the shader. So we get all this wind is generated procedurally, and they're all swaying backwards and forwards very nicely entirely using shader graph. Let's have a look at water. So water here is using a second camera, and that second camera is being rendered to a render texture. And if I now open up the water shader graph, we have a pretty cool cube visualization of this. And zoom into this node set up here, we've then got that render texture being passed in to the shader graph. So you can actually take a camera rendering to a texture and then feed that into shader graph to use. And if I go a bit further up the shader graph and zoom in, you'll notice that the caustics, so the deformation of that texture is being used by noise being scrolled together. With shader graph, you can visualize how the noise is being influenced. So we have two noises scrolling in different directions. They're sort of being merged and combined here to create the caustics. And if we go down to all the way down to the very end, we're just using a sprite unlit master to then render out that water shader. So you can take this water shader graph for sprites, apply it to your projects, tune it, tweak it. So here we've got some settings such as strength. We could change like the wave amount. We could change the caustic brightness. So if you want to, I guess, more oily, you could change the ripple scale as well. You could change like how much the caustic's actually influencing the texture. You get lots of different settings, all created from shader graph. I don't think any code was put together to sort of create this water effect. And one of the last things I want to show you are those spirits. So in the project, day shifts to night. And as we do this, these little spirits pop out. These spirits, as you can see, have this kind of like Fresnel outside edge. And if I enable this wand here, this is basically a duplicate wand than what the character picks up. As the wand comes into this area, notice it's lighting up the tree and lighting up different areas. But you notice that the details on this spirit are actually becoming more profound, more basically more noticeable. And this is all done through shader graph as well. Now, if I actually select this spirit, you might be surprised to notice that the spirit imported asset actually looks like this. It's actually a series of different details baked into different channels. So we have the red channel, which has this kind of, I guess, evil mode of the spirit. The green channel, which is this kind of like good spirits, I guess. And then the blue channel is that kind of edge glow as well. And it kind of looks a little bit tribal here, I guess. But it doesn't look like that here. So how is it going from this kind of setup to this one here? And how can I actually select this sprite and actually move the slider? And you notice it actually blends from like an evil, like a, I guess like an evil spirit to like a good spirit. How is this all possible? So if I open up the shader graph for these spirits, again, there's a bunch of nodes. What you'll notice here is that we use sampling that sprite, and we're actually splitting out the different channels. So we can actually take these channels and get the red channel, the green channel, and the blue channel, and use them in different scenarios. So we can split these all out, and then we can blend them and apply lights to them and use them with the masking system to be able to highlight different areas. And if I go to this blackboard on the left here, what you might notice is that we have this vector2, a 1 position with this reference to source position. And from script, you can say, get the position of the wand and pass it in here. And this is then highlighting the influence that the wand has inside the shader. So it's getting that 1 position and it's calculating the distance and then setting up kind of like a range that it's being highlighted or not. So you can feed in positions of assets or positions of transforms or data from components. If you're a programmer, feed that into shader graph and actually use that in your effects, which is how these spirits are then being influenced by this wands position. And if you want to learn how to do that with shader graph, you can actually just look at this project, look at this little script on the wand, and then see how this effect was created. And of course, because with shader graph, you can expose different things. I could make this like spirit, I don't know, like more yellowy. We could have the edge to be, I don't know, a bit more red. You could basically do some really neat procedural changes and basically change the visuals of your project quite a lot. It's very fun to play with. And of course, you can output the masking as well. So you get lots of different things to play around with. So if I then turn the lights back to day, let's have a look at post-processing very quickly, and then I'll jump to some questions. So Universal Render Pipeline, when you install it, comes with post-processing. This post-processing has been built to be very heavily ingrained with the Universal Render Pipeline. in that it's performant. It works very nicely on devices. It's very fast. You can have Bloom on some mobile platforms, and it's actually quite performant. You get a lot of these different settings. And in this project, there's a post-processing volume being used to light everything up. So if I find this volume, which is here, what you'll notice if I turn off the volume, it's might be a little tricky to see at first, but if I turn off this volume, notice that we don't have as much glow around the edges of the trees. And if I get that point light back, that bright point light that I'm using, notice that we have more of a harsh edge without the post-processing enabled. Whereas when I turn it on, notice that there's a bit more of a glow. So with using post-processing, you can actually make your lights stand out even more. You can go from lights being a little flat or a little simple, I guess, or it still looks pretty cool and still great to sample it to different parts of a sprite. But with applying post-processing, you can really make it feel like the light is really hitting the different sprites and hitting the different environment parts. And if we have a look at this post-processing stack, it's actually quite simple. There's a couple of settings for the white balance, so we can actually tune and change the temperature of the whole scene. So you can actually tune the white balance temperature, so it's more of a cold, icy environment. This is Denmark currently, or more warmer climates, which would be nice to go visit. We have tinting as well, so you can make things more garish and more bright, or we could have things a bit more saturated. And you also get some settings with bloom, so we can actually like make the bloom even more intense. We could search as this, so all the hot spots from the lights are actually being influenced now. You might be able to notice the influence of post-processing a lot more with the 2D renderer when it's turned off and when it's turned on. We also have a little bit of vignette as well, just to darken the edges. So post-processing works with the universal render pipeline and also the 2D render as well. So you can apply really beautiful post-processing to your 2D projects when you use this tooling. And it ties very neatly with shaders and also 2D lights. So let's just go back to my slides. So that's pretty much the end of this session. I have a little bit more information to show you, just kind of where to go, where to get started. So if you go to this 2D tools evolved, so Unity features 2D tools, we have a page which basically has a link to pretty much everything I said, but like maybe more detail and lots of other extra information. So as we go down here, we've then got individual videos or individual examples on the animation system, the lighting system, shader graph, tile maps, because this project uses tile maps for the crypt environment, sprite shapes, sprite tools, vector graphics, pixel perfect retro games. We've got blog posts, all these different things. So this is a really great starting point to go through and find all these different resources and find all these different videos and blogs. We also have a link to the Lost Crypt project. So everything I just showed you is available right now for free. If you go to the asset store and go to the Unity Technologies publisher page, or follow it through this 2D Tools evolution page, you can then download this project, dissect it, play it, have fun with it. It's running on 19.3. So download 19.3 and then open it. Myself and other people from Unity and the R&D team and marketing and all sorts of different people are sort of having a look through comments or feedback and things. So if there's anything you want to give feedback on, or you're curious about, or you want to know how something was done that this video or this webinar or information we already have is inspired, let us know. And then we're happy to amend or create more materials or answer your questions. So yeah, you can download it and get started with it right now. Hopefully this webinar was helpful. I know it's only 1 hour. I could probably sit here for 5 hours just playing with more lights, make a disco Lost Crypt level. If someone does make a disco Lost Crypt level, please send it to me, because that would be amazing to see. I'm now going to have a look at the chat and see if there's any sort of extra questions that people want to, any questions that people might have. So let's have a look here. So how did the day to night change happen? So this was done by, oh, hang on. So I explained this a little bit earlier on, but basically it's a script that references a series of subscripts that basically have gradients and settings for what the light should be at different points of when a slate is changed. So if I actually jump back into the editor, oh wow, that bloom is very, very bright right now. Okay, let's turn this down. So we have here this light color controller script with a slider that goes from 0 to 1. So 0 being daytime, 1 being nighttime. What this script actually does, if you can open up and study the code, it goes to the child objects. And these child objects basically have this like material or a material color set or this light color setter. And this light color setter basically has this gradient to say, when it's 0, this is what the color of the light is. When it's 1, this is what the color of the light is. So from day to night. So as you move that slider, sorry for that. As you move that slider, it's basically going to set the color of the lights. Like you have a script or an animation clip that says, change this color of fire from red to yellow or something like this. It's exactly the same thing. You have the script that basically change these settings. So you can set up different gradients for daytime, nighttime, dusk, all these different things. So definitely download the project, have a look at this light color controller, and then have a look at these little light color setter scripts as well, and these gradients. You could play around with them, make some disco, Lost Crypt, different types of moods, different types of styles. It'd be really cool to see. Really cool to see this. So let's have a look at. Sorry. There's a couple of other questions. Day night. With post-processing, it's possible to select layers that are affected by a volume. Sorting layers, I'm not sure. Render layers, I think you can, but that's off the top of my head. Don't quote me on this. I have to go test that. Bunch of errors when you open the project. If you can share the errors or message the errors to me or message it to one of us, we can have a look in. We need more information what those errors are, if we're going to fix them or see if they are errors or if we need to add some more information. The cost performance of these lights post-process. So yeah, obviously the more you have, the more it costs. But from my perspective, what are the things you need to watch that affect performance? So someone from the 2D R&D team could probably chip in a little bit more about this. But basically, the lights are then drawn onto the sorting layers that they are targeting. So if you say this point light goes onto background and this same light goes onto foreground, is then going to shade for these different sorting layers. I think there's some discussion about combining this or reworking this or something, but that's how it currently is. So the more you have, the more point lights that you have influence different layers, the more lights there are, kind of like the more performance you're going to have. This project has a lot of lights, like I don't know how many, but like quite a few, 40, 50 lights or something. And it runs on a phone at 30 FPS, all the real-time lights without us having to do really much changes or much restructuring the lights. So yeah, definitely be careful of taking lights. And if you have many sorting layers, like 20, and then placing a light casting onto all 20, it's going to be slower than, say, that light casting onto like one sorting layer, for example. Does this work on Unity UI? In general, the 2D lighting system, I don't think works on Unity UI. I haven't tried that, but that's an interesting use case. The Unity UI does work with the universal render pipeline and the 2D renderer. We actually have Unity UI in this project. Just as a side note, completely unrelated to kind of anything I talked about. So if you actually build the project to mobile, we actually have these like little on-screen buttons where you can like run and jump and test on a mobile device. So that's all using Unity UI. Lighting affecting it, I guess you'd have to use like shader graph to influence that. I haven't tried that, so don't quote me on that. I have to try this up. Yeah, I'm just having a look through the questions. Explain how to start on a quick setup to use the volume script you just showed. I just tried on my project and I can't make the volume script make any effect at all. So let's see if I can answer this question. So currently I turned off this volume, so we don't have a volume applied. Basically, when you install the Universal Render Pipeline and you go to the Render Pipeline asset, we have here a option. Is it here? Oh no, it's on the camera now. Yeah. So we have on the camera this post-processing toggle. I think by default this is turned off for some reason. I don't really know why. So if you turn on that post-processing toggle, and then if you go to like game object, let's just create a empty game object. Create a volume. Create a volume as well. And this is a global volume, and make a new profile. I can then basically add. So we now have bloom influencing onto different parts of our scene now. So if you just add that volume and make sure on your camera you have main camera, you have post-processing enabled, you can then just add your volume component, which comes with Universal Render Pipeline and HD Render Pipeline as well. And then you create new, and then basically you can then start playing with it. It's very straightforward. Yeah, very straightforward. And actually we've got this pretty cool sparkling on tops of the lights now, which is pretty neat. A couple of people asking for what's the link to get the project. So if you go to the asset store and search Lost Crypt, then you can get it. But this is the main page. So I'll leave this link up. So this link is unity.com/unity/features/2D tools. Okay, let's have a look at the other questions. Question about, is this session is quite similar as my presentation Unite Copenhagen 2019? It's very similar. It's basically very similar tooling that we showed. But the one I showed at Unite Copenhagen was a little bit of this project and a little bit of the Robbie Swifthand project. And this time I'm just showing this project because it's quite a new, more up-to-date thing. This project has a lot more use cases as well. So it's very similar. What I said is almost similar as well. Yeah, so I think we're over time now. If you have some other questions, reach out to me on Twitter, or I assume this link will be sent out, or some kind of follow-up will be sent out as well. Thanks for dialing in from wherever you are, from the if it's your morning, you're eating breakfast while watching this, if you're watching lunch, if it's you're eating dinner, it doesn't matter where you are. Thanks for tuning in. Hope it was a lot of fun. Hope a lot of people are going to download this project or play around with the 2D tools. I can't wait to see lots of really cool things that people are going to make. Disco modes, emission glow modes. People are going to make some really, really beautiful stuff. It's a lot of fun playing with it, and I kind of forget that I'm at work sometimes playing with it so much. So yeah. And thank you. Yeah, back to the game. They were great to work with. Super, super cool bunch of folks. Reach out to them if you want to work with them. They're awesome. Highly recommended. Thanks for joining. And I'll be monitoring like comments and stuff. Not monitoring, I mean looking at the comments and stuff on the video if you have any further questions that you want more information on. So yeah, thanks for coming along. Hopefully we could do more of these in the future. It's a lot of fun. Welcome to the new decade and the first webinar of the decade. It's all up from here. So that's great. Cool. Thanks for dialing in.